Okay, we're on day 3 of module 10 here with proofs. Our success criteria and learning goals are going to be still with mathematical proofs, but with a little bit of emphasis on triangle similarity, and we're going to be looking at 2-column proofs as well instead of paragraphs like we did the last time. Okay, so the difference between, again, day 2 and day 3 is day 2 we were doing stuff with paragraph proofs. This is what we call a 2-column proof. This is how the setup looks. It has these 2 columns like this with statements and reasons. You're still going to be given something. You're going to be wanted to ask to prove something as well. So sometimes I'll give you diagrams. Sometimes you can just draw your own diagram as well. So that kind of stuff will help as well as we go through that as well. So we're trying to prove that these 2 triangles are similar. This is what I've been given. I've been given the HGH over JK is equal to the proportion of HI over KL, and that those 2 angles are equal to each other. So my first statements are going to be whatever's given, okay? So I'm going to put GH over JK is going to be equal to HI over KL, and my reason is that it's given to me. And then I also am given one other thing. Angle H is congruent to angle K, and that's also given as well. And so I'm trying to prove that the 2 triangles are similar. So this might be easier if you just draw these 2 triangles together. They do not share points, so they're going to be 2 separate ones. I don't know which one's bigger, which one's smaller. It doesn't really matter. But if I put H here, then we're going to put K. We're going to put K here, and we're going to put little lines there. Those are congruent. And I'll put I here, and sorry, HI will go there, and then K and L will go here, and then we have G here and J here. Okay, so what this is saying is that H, the proportion from G to H and J to K. So for example, let's just say this is 4 and this is 2, okay, just for common sake. So if I took and divided those 2, that would give me 2 over 4, right? Then also the distance from, let's say this is 6 and this is 3, that means that has to be equal to 3 over 6 as well, okay? Which it is. If you divide both those, it comes out as the same. So that's what that's talking about. So if I look at this, I have 2 sides and an angle that's in between that are proportional and congruent. So because of that, if you guys remember, we had the 3 rules that showed triangles were similar. Angle, angle, side, 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 which sides are all proportionals. And then side, angle, side. This would fit under this third one. So I can state that angle or triangle GHI is similar to triangle JKL, and that's because of my side angle side theorem, or my rule. And that's proof. So I don't have to really do if-then statements in here. I just am putting it together as you see it here. Okay? And we're always, because we're using triangle similarity, we're always going to come back to one of these 3 rules. But again, drawing pictures might help you. I suggest doing that. Okay, let's look at the second one here. So again, I'm trying to prove that these are similar. So I either have to use angle, angle, side, 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 or side, angle, side. One of those 3 have to be the case. Okay. So if I look here, I've got angle S and V are congruent. So that's going to be my first statement. And the reason is that it's given. So I always put those first given stuff, and that's the only thing I put in there so far. Okay, this one's a little bit different from the first one because see how I have these angle T's that they share. So this one is going to look something to this effect, and T is going to be that middle one. Okay, I also have S is congruent to V, so I know that S has to be the same as V up here. And then this has to be X and U for this as well. So if I look here, I know that these two angles are congruent to each other. And then because they share this, guys, angle T has to be equal to each other. So angle, we'll go STX is congruent to VTU, meaning that these two angles, and that's because they are vertical. These are vertical angles. And again, I can see that because they're sharing in this statement, so they have to share for that. Okay? Well, guys, does that enough information for one of these? And it is with my angle rule. So I just state that triangle STX is similar to triangle V. This would be VTU. I don't know why they put this way, but it should be the other way. And the reason being is because of my angle theorem. And that would get me to what I'm wanting to prove and what I want to finish with that. Okay? So again, with these triangle similarities, we're just trying to use one of the three, and we're putting all the given parts and then trying to state whatever else I need. Again, if you need a picture, draw a picture. That will help you as well. So, all right, that's it. We'll see you. Bye.